Problem 63, we're trying to sketch this graph. So we have y plus 3 equals 2 to the x. And if I want to sketch the graph, the first thing I'm going to need to do is get y by itself. So I'm going to subtract 3 from both sides, giving me the equation y equals 2 to the x minus 3. That's a transformation of our parent function of b to the x, and the b value being 2. So our normal parent function has an intercept right there. That point there at 1, 2, because when x equals 1, 2 to the first is 2. I would have a point 2, 4, because when x is 2, 2 squared is 4. I also then, when I get into negatives, so negative 1, 2 to the negative first here is going to end up being 1/2. And it's going to keep getting smaller and smaller, and it's going to have an asymptote. But it is exponential, and it's going to grow that way. That is the parent function of 2 to the x. However, this minus 3 is now a k value, and it moves the graph down 3 units. So where I have a asymptote right here, that asymptote and the graph all get shifted down now, that k value, which is negative 3. So my graph now looks like this. So I need to now figure out for problem A the domain and range of that function. So the domain for this function, it's going to go to the left forever, and it will go to the right as well forever. It's just going to take a little bit. It's going up very quickly here, but it will go to the right forever. I have every possible x value left and right. So my domain is all real numbers, or written as negative infinity is less than x, which is less than infinity. The range here cannot be negative 3. It cannot equal negative 3, but it will go up forever. So the range here is going to be y values that are greater than negative 3. Not or equal to, because again it's an asymptote and it'll never touch negative 3. So on this problem again, then let's take a look at some x and y intercepts here for problem C. So an x-intercept, not quite sure what that is, but what we can do with our original function is right now we can go through and try to use some guess and check with our calculator. In a little while, a few more lessons, we're going to learn how to solve this. But right now we don't have the skills to do that, so at this point all we're going to do is guess and check with our calculator. So I'm going to get an x-intercept here of about 1.5850. That's the coordinate point of that intercept. The y-intercept, though, we do know it is that point right there, and that coordinate point then is 0, negative 2. So a future chapter we'll learn how to figure out the x-intercept a bit better. And then problem D. What can I do to the graph in the equation so it has no x-intercepts? If you remember what I did in the very beginning, I started with my parent function, and then the negative 3 shifted down. So if I would move it back up to my normal parent function, or a k value that's greater than 1, or greater than 0 rather, I would no longer have any x-intercepts. So basically I want to take any k value of 0 or greater. So I could go with this. I moved it up 1 from my parent function, so the equation would be y equals 2 to the x plus 1. And now I have an asymptote here at positive 1, and therefore I will not have any x-intercepts.